I love grammars personally because I'm a visual person and we can draw things out. It also makes some dirty cuss word in computer science a little bit easier to manage, and that cuss word is yes, recursion. Recursion visibly does not scare us as much as visible, with code. Let's put it that way. And grammars are going to have, number one, some type of generation of different tokens that we can use in order to create different sentences from that, like we have right here. That would be a sentence from this grammar that we have now being displayed. So you can handle different structures in coding our grammar of recursion, of splits, of literally trees, and how we're able to get from a sentence to a grammar or vice versa. Now, this can be implemented using stacks, can be used using states, but we can also use it like this when we actually draw things out. And yes, again, this is a tree, so there might even be parts of recursive, meaning that there's going to be things higher in the tree that are going to wait for items that are lower in the tree to get done first so that it can do its job. That sounds a little bit like recursion, doesn't it? But don't let it scare you, because honestly, this is going to look like a tree, and nobody's upset at looking at trees. So that's what that is going to look like in this overall context-free grammar example that I have for you. Now, I'm showing you how did I get to this answer. You can click on that. It'll probably be the next video under this. But notice that how this is laid out. Number one, we have a grammar that's been given. And notice there's a couple of, this is reduces to, so we have exponent reduces to number, or a parenthesis, exponent, op, exponent. Now, every time that you see some names in there, you should see them show up on the left-hand side. If you don't, there might be a typo. But it's usually there, and you might have an or that's in between that, and it's just like we have with digit here. The digit can be 0 or 1 or 2 or 3, and then go from there. But be careful. I want you to take a look at num here. Num can be broken down or reduced to a digit or a digit and a num. Now, what's so important about that is actually a little bit further down here, and that is where if we want to do a 4-digit value, I can break it up into, well, here, this would be 1,234, but I can break that up using the grammar that we just given by using num at first, and num I can break down into digit and num. There's my digit. By the way, that's using recursion in it, because it's calling the same thing over and over again in order to get to our final value in this. So that's the neat part about using grammars, and the grammars are going to look very similar that I give you to what we just did. But notice how we're breaking them down into, well, number one, let me go back to the other one here, is that we're trying to break them down into matching a sentence that we want. So we're trying to have the grammar match what's being highlighted right now, that 4 minus 3 plus 2, and see if it'll work out for now. Okay, your compiler really is trying to match, it doesn't seem like it, your syntax with what's in the grammar. It is trying, but we're not always so successful, are we? But keep that in the back of your mind as we're getting now into grammars. So I wanted to go over one other item in this grammar. And that is something I'm going to cover a little bit more, but you're going to need it for an exercise here in a moment, is that these are split up into terminal and non-terminal values. All the terminal items you'll see highlighted in pink here, and those are items that don't break down to anything else. Matter of fact, it's basically everything from those arrows that you see here to the right-hand side. Not all of them, but a lot of them. Let's put it that way. The non-terminal values are going to watch are the items that are in yellow. But they're also all these items that you see right here on the left-hand side of exponent or expression, really, op, num, and digit. They break down into something else, just exactly like this tree shows you, that all those yellow items break down into something else until finally, they select something like digit, where digit doesn't break down into anything else. That is a terminal. All these items that are here on the right-hand side are all terminal values. So be careful. There is a mix of terminals and non-terminals, and that's again why we use the parse tree to help us really understand what's going on. But notice that all the terminals are at the very, very bottom of the tree. So that's one way of checking your answer, especially for the exercise that's about to come up.